Okay, so Keysource has launched something called Keysource Artificial Intelligence, or KAI. Do we call it KAI or Kai?
Yeah, Kai's a good one. Yeah.
Yep. And really, can you just give us a sort of high-level overview of a bit about this solution?
Yeah, no, absolutely. So Keysource is always interested in innovation and helping to tackle some of the industry's key challenges. Kai is the first in a series, hopefully, of new innovations over the coming months. And what we're really looking at with Kai is tackling really a growing trend in edge facilities and the management of edge facilities, coupled with one of the, I suppose, most common threads of challenge, which is the availability of highly skilled resource to manage those facilities as they compound each other. And we looked at two key behaviours, which is what Kai was born from. So behaviours in facilities management and engineering, so fixing things that aren't broken too early, in which case clients are investing in life cycle replacements when they could actually sweat the assets, or fixing things too late, which, as you know, in our industry isn't really an option. You're either causing an outage or you're exposing a service to an outage. So looking at those kind of two key behaviours or kind of typical challenges that we're seeing within the industry, Kai was really born out of that. So what is Kai? So Kai is a sensory network. So we're deploying a hardware sensor network to client sites. We're connecting it with the cloud. So Kai is a artificial intelligence and machine learning service in the cloud. And it's not a sentient being or anything like that. Obviously, its current form is really looking at mathematical algorithms to crunch numbers, to look at complex data, and to make sense of it, to look for changes, to look for patterns within that data. And we're combining that latest technology with our 40 years experience of designing, building and operating data center facilities globally. And the best way for me to really describe how that actually works in practice in high level terms is if you were to put yourself in the shoes of an experienced engineer. They're able to walk into facilities, use their ears, use their eyes, use the sense of feel to understand what's going on. They might hear something's a little bit out of kilter, so a pump, a motor, fans, etc. And they might be able to diagnose something straight off the bat, coupling their experience with their feelings. So what we're trying to do with Kai is replicate that, but overcome some of the human elements. So typically we're all people. We're all suffering from the same thing. So we all need sleep. We all need to go on holiday. Current climate, obviously, is a high risk of illness, which we want to protect our people from as much as possible. And there's also the natural ebb and flow of knowledge and experience within companies as personal circumstances change and people's careers develop in different ways. So Kai is able to take the human sense element. So we've got that sensory network, and we're looking to mimic that. We're looking at creating a digital fingerprint from that data. So that's that element I was talking about, patterns. So we're able to use those patterns to then look at normal behaviour and draw a line on normal behaviour, and then look for changes in that state. And as well as normal behaviour, where our experience really comes in, is to be able to teach, as you would an engineer, teach Kai what that change of state means, so that next time it sees it, Kai's able to identify exactly what's happening and therefore start to reduce that mean time to repair and automate that process. And with that sensory network, typically what we're seeing is that anywhere up to 9 months before a fault, we're able to see that change of behaviour and then better plan and respond to those changes before they become a fault.
Cool. And it's focused very much on the edge. So what sort of elements does that mean? If you said, because obviously we've got different types of data center IT environments. What specific sort of edge issues is it looking at?
Yeah, so as we know, edge by its nature is it's covering its regional deployments of equipment, small and large, to match the requirements of society. Low latency connectivity, high consumption of data. A great example that we've seen recently is we've done a project with Dell, deploying edge facilities, and two of those locations were in the Arctic Circle in Dubai. So they're 7,000 kilometres apart, minus 35, plus 50 degrees centigrade, so really different environments. And so Kai is really aimed at those types of facilities where they might be small footprints, but they're still critical and essential to delivering a service. And we're able to deliver a consistent service across those locations by having that always on 24/7 service from Kai, monitoring change, looking for that behavioural change, and then helping to really, to really identify before it becomes a reactive measure. So we're able to integrate that with planned maintenance strategies, and save some money there in terms of travel and associated carbon, and kind of, I suppose, the key point in terms of that compounding factor I mentioned earlier, where you've got edge with a huge geography, and you've got the resourcing issues associated with highly skilled engineers. I think I saw some stats recently that I think it was Randstad that said there needed to be something like 120,000 engineers employed every year until 2024 to cover the skill shortage. And I think it was Engineering UK a year or so ago that said that they polled a load of businesses, and 61% said they weren't confident of filling that skill gap. So really Kai is trying to provide or help to fill that skill gap, reduce the risk of outages, reduce the mean time to repair, improve the availability of engineering resource, so they're not reacting and travelling just for just to fix one thing. They might be able to go with a planned maintenance regime and cover off several items really in one hit.
Okay, and you alluded quite a lot to what goes on it, but just can you talk us through the sort of service from, I guess, I think there's an initial sort of audit, and produce this digital fingerprint, and then obviously there's some meaningful data at some. So how does that work? Yeah,
no, of course. So there's 5 key steps. Kai starts with that engineering audit. So our in-house expertise comes to the front. The engineering team go to site to review the current state of the infrastructure, look at the history of how it's been maintained, and help the client to understand, what bits of infrastructure are going to benefit most from that sensory network. We can look at existing data as well, but for me, the real benefit comes with that human sense element. Then what we're able to do is step 2 is to work with the client on how that sensory network connects up with the cloud. We've got to consider security, and how the information passes and what information passes. So ensuring that security is covered off is an essential part of that. Once we've got that connected to Kai in the cloud, we can generate, start to collect data, which is really, the richness of the data is what makes it. Kai can then analyze it and create that digital fingerprint that we mentioned, about what normal looks like. Once that digital fingerprint's created, the engineering team come back, they take a look at it, they look at the history, they look at their experience of how that infrastructure has worked, and to basically say, we're comfortable that that infrastructure is in good condition, that is normal working order, and it's not hiding some sort of underlying problem already that we might miss otherwise. So we've got a clean slate and we're starting it off and looking at it then. And then the final stage really is green light to go out of the box. You're going to be looking at changes within an agreed tolerance of what's normal, and then investigating and teaching Kai, using our engineering expertise, what that change in state means, so that the next time it sees it, it can automate that functionality and start to say, right, this is what that problem is, and this is how, what steps we need to make it. Could even get to a point, we're not there now, but we could even get to a point where we're ordering parts and components and all that sort of good stuff. But that's all part of the journey.
Okay, and in terms of the benefits, you've referenced sort of maintenance quite a lot. There's that, and what are the other sort of obvious, I guess, as it develops, you'll find more and more uses for it, but what are the sort of obvious pluses at the moment?
I think the key benefits really, as I've sort of highlighted it, it's really around providing a consistent service. The benefits that come with that consistent service and that planning aspect of it is a reduced capital cost in life cycle replacements. So companies are able to sweat their assets longer because they understand what behaviour and what trends are available. It's an intelligent predictive analytics platform really, and what we're also able to do then with planned maintenance is not just the capital savings, but we're also looking at the savings associated with early identification of a change of state before it becomes a fault. One example of that is really looking at maybe a refrigerant system that BMS isn't tracking, that it's tracking some changes in the way that the compressor is operating, for example. It's stepping in and out, but it's not really interpreting that data as a fault. So what we're able to do is identify that there is a change of state when we investigate. We identify that there's a refrigerant leak. We can fix that for a few £100 versus a compressor. If it was left to carry on, the compressor would fail because it's stepping in and out, and that would cost several thousands of pounds to replace, not including the challenge associated with having to with edge facilities to fly engineering resource out, etc. So you've also got that saving of time and the reduced cost associated with maintaining those edge facilities, which are often quite a lot smaller and don't warrant on-premise facilities regimes, or certainly not expert engineering on-premise. So you've got that capital saving and that time saving, and obviously with that as well, you've got a carbon saving from the point of view of reduced transport, travel, flights, etc. And even in the current climate, thinking about it, you're reducing your engineers' exposure to any potential trouble associated with the whole COVID-19 situation and any future conditions, etc. That answers the question.
Yeah, and in terms of the parameters, a lot of these things, I guess, out of the box, it has sort of a standard software, but can you also obviously override or set your own parameters? Because I'm just thinking, it might be flagging things up and saying you need to do stuff, but if you know you're going to go to that site in a week's time anyway, you might say, etc. So how does it work, the automated bit and the human bit, if that makes sense?
Yeah, no, absolutely, that makes perfect sense. So really, we're delivering this as a service to our clients. So they don't need to worry about getting more alerts than are required. We're providing that as a wrapper, full wrap service. It is possible to tailor certainly the tolerances in terms of how much, what constitutes a change in behavioural state, and we'll start to tailor that as we understand different sites and locations. Each one might have a slightly different tolerance depending on what type of infrastructure it is. What the client's looking for, etc. But obviously, from the point of view of data and continuity and learning, what we want to do is ensure that the data sets amongst different sites are as similar as possible, and that way Kai can learn that much faster and share deliver that shared learning across multiple clients. So it's not just reliant on learning locally within one particular siloed environment, but taking a more holistic view and learning as a whole.
Cool. And in terms of back to the sort of edge focus, is that just because that's seen as the big growth area within? I know the edge means different things to different people, from, as you say, sort of regional data center right down to a sort of little kiosk on the corner of a street, if automated vehicles and all that take off. But is that why you're focusing on it, because it's the big growth area, or are there other reasons? Or?
Yeah, I think edge is obviously a topical subject at the moment. I think obviously hyperscale and the cloud growth in the cloud is still an enormous growth sector as well. So I don't think edge is the only area that's growing, but certainly from the point of view of the challenges, edge being geographically dispersed, different regions around countries, and even spread globally, and it really kind of highlights and compounds the challenge associated with managing and maintaining those facilities. So getting the right people to the right locations, getting a consistency in the way that you're delivering a service, and reducing the risk and exposure. They're the real reasons why we're sort of focusing and honing in on edge, because that's where the real pain points are, quite frankly. I think this type of service really applies to all critical facilities, not just edge, but the similarities there, the benefits are mirrored across small and large facilities. So I think certainly we'll see approaches like this coming up, and services that really going to be required to manage first and foremost the edge networks.
Cool. And I think right at the start you alluded to the fact that this was perhaps the first in a number of modules or services. Without giving away sort of trade secrets, whatever, are you able to sort of hint at what else you're looking at developing, bringing to the market?
Yeah, I don't want to jump the gun too much, but certainly from our perspective, we're looking at the key challenges. We hear a lot about the art of the possible, especially when it comes to artificial intelligence and some of those buzzwords. We're not going to get caught up in what might be possible tomorrow. We're really looking at delivering a series of innovations that are able to deliver real benefits today, and first and foremost, those initial innovation projects are really going to be delivering on the challenges associated with the topics we've talked about today. So edge networks, remote working, engineering, upskilling, or support from critical facilities engineers globally. So I don't want to give away too much, and we'll hear a lot more about that in due course. But certainly the topics are very similar. They're all links intertwined. So,
okay. And just one other thing occurs to me: was this software? Did you work with some key sort of customers within some test environments to hone this, or was this sort of straight out of the box? I guess it probably isn't, but how's it sort of come about working with potential?
Yeah, so we worked with a couple of our key clients in developing the solution, and a number of key partners behind the scenes. It's really been tested and built up over the last sort of 12 to 18 months. So long in the making in terms of trial and error and what we find does work, doesn't work, what sort of volume of data. We started off and with quite enormous volumes of data to manage, and realised quite quickly that you lose some of the benefits of sharing experience and learning from between sites. So we've learned quite a lot during that process. And I'm sure there'll be a bit more in terms of the clients and partners that we've been working with, coming out in the coming months in the form of case studies and that sort of stuff.
That's brilliant. Well, I appreciate your time, and thanks very much indeed, Richard. Thanks.